Okay, we are live. Hi, everybody. Welcome to the GTG Cloud Wrocław event. Today we have Pradeep Badani, and um, you can ask the questions to the in the comments on YouTube. We will read them at the end of the stream. For most active of yours, uh, we have JetBrains licenses for any product for 1 year. Uh, Yeah, and I think that's all. So, Pradeep, stage is yours.
Thank you. Thanks, Carol. I hope you're able to hear me clearly.
Yeah, I was able to
Good,
hear you clearly.
good. Hello, everyone. Welcome to this session, and thank you for taking time and joining this talk. Today, we are gonna discuss or learn about the Terraform and how we can leverage the Terraform or use the Terraform to deploy infrastructure on the cloud. For this talk purpose, we are gonna use the GCP Google Cloud Platform as an example, but similar concepts can be applied to other clouds and providers available for Terraform. So quick about me. I'm have like about 11 years of experience in different fields like big data, cloud, and DevOps. I'm a Google Cloud developer expert, Google developer expert in cloud category, and I have been through a couple of Google Cloud certifications. And I try to write cloud stuff on my blog. So please follow up on pbhadani.com for the blog content. Just to set an agenda. So in this talk, we are first going to understand what is infrastructure automation, then learn what is Terraform and how it can help us, or how do we work with it. Then how do we set up the Terraform on our local workstation, and then a demo to deploy a few infrastructure resources onto the cloud using Terraform. So let's just first understand what is infrastructure automation. So infrastructure automation is a way to build and manage the infrastructure object. Infrastructure object can be like network, VM, firewall rules, security groups, etc. Using some sort of code, and it which does not require any manual human intervention. So it could be like the automation could be done through the scripts or tools like Terraform, so that we automate or we write what we want on the infrastructure side, and that code creates those resources for us without having to go to the like let's say web UI, clicking on here and there and deploying the stuff. So what we get from these automation instead of doing things through the UI, so we get like a faster delivery. Things like once we have source code or scripts written, we can deploy the similar type of infrastructure again and again for multiple teams at a faster speed than going through the UI. Also we get like a consistent output, so we get like we achieve better reliability. It's basically removes like a human error, which can happen when, let's say, if you forgot to click on some place, or let's say there's some UI element has changed and we are not able to find or supply those values properly, etc. Also, as it reduces lots of manual steps and like errors, hence it can also reduce the cost. It lowers the cost of deploying the stuff, maintaining the resources on the cloud, and it enables a collaboration between the team. So as you have everything written as a code, multiple people can collaborate on that code through, let's say, PR, like peer review, or maybe developing that code on ticket by ticket basis, etc. So what type of tools we have? So there are like a variety of tools available, and they evolved during once these cloud environment came into the picture. So tools like Terraform, Chef, Puppet, Salt, all these tools try to help us to achieve the infrastructure automation. Then there's this new concept called infrastructure as a code. So it's a infrastructure as a code is an approach to manage these systems like cloud resources, like networks and other objects through source code. Like we create resources or we create programs or application using, let's say, Java or Python. In a similar way, we are going to use some kind of a language to basically define what type of infrastructure we want, and that code is going to create that infrastructure in a reliable way. And that concept is infrastructure as a code. So it gives us a lot of benefit, like we can, once we have a code, if we run that code again and again, we are going to get a consistent output. We can repeat or modify that code and get a similar kind of infrastructure again and again in a maybe in the same environment, in a multiple environments. If we want to make some changes, we can go through the change management instead of going through the UI. And again, it fosters the collaboration between the teams within the team and between the teams in an organization. For this talk purpose, we are going to focus on the tool called Terraform, which is uh, uh, industry de facto tool. Like a lot of places, this tool is being used. Terraform allows us to do infrastructure as a code for cloud and other stuff as well through its provider, which we are going to see in coming slides. It's an open source tool. It's written in a Go language, and the website is terraform.io. And if you want to look at the source code, you can find at github.com/hashicorp/terraform. Terraform release cycle is frequent. It could be like a fortnightly or every 3 weeks. You can see some minor release of the Terraform. So it's actively developed tool. There is a big community. So yeah, there's a lot of traction for this tool. And Terraform uses its own language, which is called HCL, HashiCorp Configuration Language. And it's a declarative language where we can define the objects, and based on that definition, it's going to interact with the APIs, relevant APIs, and create the resources. So now let's look at the feature. First of all, it's platform agnostic, which means with the Terraform, we can manage heterogeneous environment. For example, we can create resources, some resources in, let's say, Google Cloud Platform, some resources in AWS, some resources, let's say, on a GitHub or maybe Jira, etc., using the same workflow and the language. Uh, there's a common misconception or a common question I get it. Does it mean that if I create a resources or let's say some Terraform code for Google Cloud Platform, can I just simply convert into the AWS? That doesn't actually mean the platform agnostic. What it means is that you learn like a language, which is let's say HCL and the workflow, how Terraform works, and then you can use those concepts to define the resources available in Google Cloud Platform or AWS or Azure or somewhere else. Okay, it has a concept called Terraform state. It keeps tracks of the resources it creates. So it helps us to understand what sort of resources are there, what sort of change we are going to do, or what sort of change has been done to the resources, maybe outside of the Terraform. So it really, the state management really helps in understanding the state of the infrastructure. Then it is also quite intelligent enough to infer the dependencies between the different infrastructure object we have defined. For example, let's say we are writing a Terraform code where we define Terraform to create a subnet and then create a VM instance within the subnet. So obviously, what if we have to do with the bash script or some scripting where we have to define these dependencies to, let's say, make first create the subnet, then wait for subnet to be available and then create a VM. But in Terraform, it can detect these dependencies and it will automatically wait for it will first create the subnet and then create the VM within that subnet. So it can easily identify the dependency implicitly. Sometimes we might need some explicit dependencies, so it also allows us to define the explicit dependencies between the resources. Also, before creating any resources on the cloud or on any of the provider available with the Terraform, we can do something like dry run, which is called as an execution plan in Terraform world. So we can do Terraform plan, and it will show us what is it is going to do, what sort of resources it is going to create, or maybe some properties it is going to change if there is an existing infrastructure created by the Terraform, or if it's going to remove some infrastructure and all this stuff. So it's this the execution plan is really helpful to understand what what is the current the whole picture of our infrastructure, and what the code is going to do with that picture. Also, it can also produce a resource graph. So if you want to see the dependency in a graph format, we can do that. And it tries to create the resources in parallel as much as possible, instead of doing serial creation. And we can control like the level of parallel. And if there is any use case, if you want like a really like a kind of serial execution, we can reduce the parallel execution to, let's say, like a 0 or 1, so that it just goes to the serial execution. I hope so far things are clear. If you have any questions, please feel free to put on the chat, and I will take those questions at the end of the talk. So let's just understand some of the concepts of the Terraform, some common concepts. So first of all is Terraform provider, which is a very core uh, concept of the Terraform. So Terraform providers are actually the plugin which translates the API interaction with the services. So for example, if I'm using a Google Cloud provider, what it is going to do is it is going to translate the definition which we write in a HCL language, and it's then gonna translate those definition and make the interaction with the Google Cloud API, and also helps us to do authentication and all those stuff. To use the provider, what we do is we use the provider keyword and then the provider name. This is not any random name. The provider names are published on the Terraform website based on the for each provider there is a unique keyword. So for Google Cloud it is a Google, and then each under the provider block it will require some set of properties to define. So for example, for Google Cloud provider, we need to provide like the project ID, like which project we are basically gonna create these resources and do stuff. And also like if you want to define like a default region and all those stuff. And there are like on the documentation we can find a list of arguments or a list of properties which you can set. Some are required, some are optional, but at least required properties needs to be set to use that provider. So far, like it's almost about 35 officials providers are listed on the HashiCorp Terraform website, and there are almost more than 200 providers which are in a verified state, and there are many more community providers. If you want to look like all the providers, here is the link. You can follow this link, which will basically take you to the Terraform documentation, and you can find all the available Terraform providers. You can filter it from here. So if you just want like official one, you can look for official. If you're looking for partners, or if you're looking from community, you can basically look for the documentation. And if you want to go for a particular provider documentation, you can click on one of them and you will get uh, the provider page, and you can get links for more documentation from here. Okay. So yeah, this is an overview. Here is the documentation link. And if you want to use a provider, this is the general construct to use the provider. And this is the documentation, how to use the particular provider. Then the next concept is the resource in the Terraform world. This is also an important element in the Terraform world, because each resource blocks helps us to describe the infrastructure objects. Infrastructure object could be like a network, security group, a VM instance, a key pair, or a storage bucket, anything which exists on the cloud, you can term as an infrastructure object. So to define an infrastructure object or a user resource, we use the keyword called resource and then the resource name. The resource name generally start with the provider or cloud name. So for example, if you are using like Google, cloud resources, most of the resources will start with the keyword Google underscore. And let's say if we want to create a storage bucket, we just need to find the right resource keyword or resource name for that storage bucket in the Google Cloud Terraform provider documentation, and then use that. And then we can provide what type our name for this resource. And then again, in this resource block, we need to fill in the properties which this resource expects. So again, some will be required properties needs to be set, and some will be optional. So for example, for storage bucket, we just say like, okay, this is the name of the bucket we want. This is the location, like Europe West 2. We want these are the attributes we want for this the storage bucket, and that's done for defining the storage bucket in the Terraform. Then there is another concept called data source, which allows to read the information of a resource which already exists. So that resource may be created with the Terraform or may be created outside of this particular Terraform project which we are working on, or maybe completely like a manual or through some script or etc. Sometimes we might need to read those resources. So instead of hard coding the values, it's probably better to use data sources. For example, let's say when we are creating a virtual machine and we want to supply the network name, instead of hard coding the network name or maybe getting the network ID through like through variables, it's easy to use the data source and to get the network ID based on some filters, like this is based on the network name, and then supply that into the Terraform configurations. So to use it, we use the keyword data and then the data source name. So for example, in this example, we are going to look for the image from the Ubuntu family. So we are just saying like Google Compute image, and then saying like the family is this, and these public images lives in this particular project. So we will be able to get the image ID when we run the Terraform. So if you want to always retrieve the latest image ID, we can just use these data source and it will always gives the latest image ID. Otherwise, if we want to have the latest image ID, we'll have to get manually from the documentation and put it in our code, which is like a hard code way, and it makes much more easy, because if the image ID changes, it will automatically get the latest image ID. Then we have this concept called Terraform state. As I mentioned, Terraform state keeps tracks of the resources which we create. So for example, if we define in a Terraform code, we define to create a Google Cloud Storage bucket, a VM instance, then those details of those storage bucket and the VM instance will be defined and will be kept in this storage in this state file. Now, the state file can live in a different places. So when you start learning Terraform, you could use like a local state, which means like the state file lives in your local laptop. But again, if you lose that state file, then the resources becomes orphan. So the Terraform won't know that, okay, some resources exist. And if you try to run the Terraform code again, it will it will see that as there is no state, there is no resource exist on the cloud, and it will try to recreate those resources. So it's better to use it's better to keep these state file in some remote places. So you could keep in, let's say, Google Cloud Storage bucket or S3 bucket or different places you can keep. And also, when you have these state file on a remote storage or remote backend, then and if you're working in a particular team, then it's also it's better because that state can be shared easily between the teams. So so that you don't have to share the state file manually from your system to your team member system, etc. Now let's understand the life cycle of the Terraform. The life cycle is pretty simple and straightforward. First, we start writing by the code. So we define a code which creates some resources. So in this example, let's say we want to create a simple GCS bucket. So what we do is we first define the provider, like the cloud provider which we are going to interact with, then define the cloud storage bucket definition, and that's it. Then what we do is we run the Terraform init command, which what it does, it initializes the Terraform project. So it will try to figure it out, the dependencies, the provider we are using in the code, any plugins which needs to be downloaded, etc. So all these things, the Terraform init will take care and downloads the required resources and configure the Terraform state file as well. Then the next step is to run the Terraform plan. This is the execution plan. It's a dry run which will tell us what type of infrastructure changes or creation the Terraform is gonna do. So if there is no GCS bucket, or this is a completely new Terraform project and it's the first time we are running, uh, which means the resources does not exist beforehand. So we will see something like this. It will show us like, okay, it is gonna create like a particular resource like Google Storage Bucket, and these are its properties like location, the name, and some information will be available once this resource is created. So Terraform will try to emit put the required answers or values as much as it knows. Some values will be available only after resource creation, so it will say no known after apply. And at the below you will see a summary like for the plan, like how many resources this Terraform is code is going to create or add, how many resources is going to change, how many resources it's going to destroy. So it's very important to review the summary and the plan before doing any changes. Then the next step is like, if you're happy with the Terraform plan, this is what we want. Then the next step is to apply this plan. So we just say Terraform apply, and then it is gonna start creating the resources which is defined in the plan. So here we can see it started creating the Google Storage Bucket, and then at the end it will say like how many resources it's added, how many resources it has changed and destroyed, etc. Now, as the cloud, the whole concept of cloud is like a pay as you go model, and like use the resources when you need it, when you don't need it just turn off. So if you want to like remove or clean up the resources because you may not need any more or etc., so what you can do is you can do run you can run the command terraform destroy, which gonna destroy the infrastructure defined by that particular terraform code. So be cautious when you run this command, because this is actually gonna delete the resources. So only run when you actually need it, and just examine the execution plan of the destroy before actually destroying the resources. Now let's get onto the workstation setup. It's pretty easy to get started with the Terraform or set up the Terraform. If you're on a Mac OS, you can use the homebrew. So you can run command like a brew install Terraform. It's gonna install the Terraform. Once it's installed, if you just run or if you type Terraform help, it's gonna print the Terraform help like command, which means the Terraform is installed and ready to use on your system. If you want more detailed like steps to how to work with this Terraform, you can follow my blog, Getting Started with Terraform. The link will be on the slide, and I'll be sharing the slide after the talk. So you will have these links and the slides afterwards. If you are a Linux user, again, you can get the package from the HashiCorp repository, and you can put into the, let's say, user local bin, and you can get started. And also, like, there are some step on the Terraform website nowadays to basically install the Terraform from the package manager as well. So if you want to install through yum or apt, etc., you can follow those steps if you prefer to do with the package manager. Then particularly for when you want to interact with a particular cloud, so in this example we are interacting with the Google Cloud, so we need the G Cloud, which is a Google Cloud SDK setup also on our workstation, so that Terraform can interact, use the Cloud SDK and interact with the Google Cloud APIs. So you can follow these commands to install the G Cloud. Also, I have a separate blog on how to work or start with the Google Cloud SDK, so you can follow that. So that's about the setup. Now let's just say like now we are in a state that, okay, we are ready, our workstation is ready, we now understand the Terraform basic concept and etc. So let's just start creating some resources, let's do some hands-on work. So let's just say this is in a sample architecture, or like a very like a basic example architecture, where we create a web server, and create a storage bucket, which web server pulls some files from it. And also web server has some service account so that it can authenticate with the storage. And then it just hosts up those files, maybe HTML files, to the users over the internet. So what we are going to do is we are going to create a web server, which is on a VM instance. We are going to create a Google Cloud Storage bucket. We are going to create a Google Service account and set the permissions, appropriate permissions, so that this web server can pull the files from this storage bucket. Okay. So this is what we are going to do in this demo. So let's just dive into the demo. The demo code is also available onto the GitHub. The link is here. It's on my GitHub under Terraform's web server repository. But let's just go through the code now and create some resources. So let me bring up the code. Okay. So this is the repository which I've cloned on my local workstation. I have the Terraform install and the gcloud install. So let's just go first through the code. So if you see, this is the root folder, which is Terraform web server. And under that, there are a lot of .tf files. So the .tf is the Terraform file extension where we define the code. Now, the common question comes up like how many Terraform files we need, or can we write everything in one file, and etc. and so on. So from the Terraform perspective, you can write all the code in one .tf file, let's say main.tf or common.tf, etc. But when you have a like a bigger infrastructure, and when you start developing more and more infrastructure, that file can become very long, and it's not that easy to maintain or doesn't become like a much more readable over the long period. So generally what I do is, and I suggest, is to basically break down the Terraform code in multiple files and give some meaningful names to the file as well, so that when someone new, probably new in your team, is looking at that code, and if the person just wants to look for a particular code, let's say maybe for a VM or service account, he or she doesn't have to scroll through the like a very big file. He can just go to the particular file and then look for the code. So here what I have is, I have like multiple .tf files. So let's say this is a vm.tf file where I have defined the source code or Terraform code for creating a virtual machine. Then I have a Terraform TF file for defining the GCS bucket. Then there is a separate TF file for defining a service account, etc. I'm also using some variables. So those are defined into the variables.tf. Uh, to define a variables, we use a keyword called variable and then the variable name. And under that, we can define its description. This is optional, but again, it's a best practice or a good practice to define the description so that it is clear like what this variable is about, its type. And if you want to set some default value, you can set some default values for this variable. So in case the user is not providing the input for this variable, the default values can be used from this particular place. And then there is something called Terraform TF wars file. So where this is the place where we define the values of the variable, so which we want to maybe provide, which are the required variables. The required variables are the variables which does not have the default values, or maybe if you want to override some variable values, so we can just use that. Okay. Let's just go through this code first. So as I mentioned, we are going to create a virtual machine. So the code lives in this vm.tf. So here I am using this Google Compute Engine resource, Google Compute Instance resource to create a VM instance and then define the attributes, like what should be the name, what should be the machine type, like which zone it should create, any tags, any labels, the boot disk. So here, if you see, instead of providing the image ID, I'm using the data source and just trying to get the latest image ID for this Ubuntu 2204 LTS family and supplying it here. Then what type of network we want, any metadata script, or and this resource, if it depends on something. So this is called as explicit dependency. We can use this keyword depends on to define the explicit dependency. So what I want is like I want to create this VM once this object on the Google Cloud storage bucket is available. After that only I want to create this VM instance. This is like my this is based on the architecture which we saw into the previous slide. And then also we can provide some like this metadata script. We can provide the shell script as it is, or we can basically provide as a template, which is much more maintainable and readable way. So I have a template of the script to install the nginx and get the web page from the gcs bucket and put it in the right place. That's why I put the explicit dependency, because my metadata script expect a web page available on that gcs bucket. And within the cloud resources world, there is no direct correlation with the gcs bucket and vm instance. They are completely separate entities, so implicit dependency won't help. So that's why I have defined the explicit dependencies. Okay, so that's about that creating a VM instance. Have a look at the GCS bucket. So what I want is I want a GCS bucket to store a web page. So I am creating this GCS bucket using Google Storage bucket, giving its name, and then which location it should be available, and then also creating the object and uploading it to the bucket. To create a service account, using Google Service Account resource, providing the account ID and all the details, and what permissions this service account I want to give. So I'm managing the permission using this resource block. So that's about the code. Then if you see, we have this output.tf. So outputs are generally help to get the values of the resources which we have created. So once the web server is available, I want the IP of that. So I've just basically put the IP. I'm just getting the IP as an output. So once the Terraform apply finishes, it will print out the outputs, and so that I can get the IP of the web server which Terraform has created. This is an important file, backend.tf. So I generally name the Terraform state configuration in a backend.tf. So this is where I'm saying like, okay, I want to use a backend, Terraform backend, which is of type GCS, and then providing its attributes like what's the bucket where the TF state should live, and what is the file name of that particular, or a prefix for that particular Terraform state. So let me just get the project ID for my project so that I can just fill it, and then we run the Terraform code. So the bucket name is this in my project. You can, when you could use or when you try this example, you use your bucket name. And just remember, like if you're not on a free tier, or if you are using like uh, instances, so running these examples may cost charges on your uh, Google Cloud account. Sorry, somehow the screen died. Just bringing it up again. Okay, here we go. And then I'm providing the project ID here. So, so let's just follow the workflow. So first step was writing the Terraform code. So we have the Terraform code. Now what I'm going to do is I'm going to do Terraform init. And before that, as I've already done, I'm just gonna remove the directories so that you guys get the complete picture as it runs from the fresh. Okay, clear. So let me just increase the font as well. Yeah. So I'm first gonna run the Terraform init. So it's initializing the backend, it's initializing the provider. So provider I'm using is the Google. Also, I've used the template provider to render the template file, which I'm using to install the Nginx script. So it says that the Terraform has successfully initialized, etc. Now the next step is to do the execution plan, which is a Terraform plan. And I can output this plan into a file as well, so that I can just use that particular file to apply instead of running the Terraform plan again. And this generally helps. So if you're on a CI/CD, or if you want to keep track of your plans, you can upload this plan somewhere, maybe on a Google Storage bucket or on your CI/CD system, somewhere you can keep it. So when I run a Terraform plan, let's just quickly say the summary. It says like 5 to add, 0 to change, 0 to destroy, and there will be this output at the end. And this plan is saved to one.plan file, and I have this file now here. So let's just review the plan. So green plus means it's going to create something. This symbol means it's going to read the data resources. If you have the red minus sign, which means it's going to delete, destroy something. And when you see the amber tilde sign, which means it's going to change something to the resources. So as this is a fresh infrastructure, everything it's going to create it. So it's going to create a data template, which is like the script. It's going to render the script and make it available for the compute instance. It's going to create a Google Compute Instance VM. Then it's going to create a storage bucket, the IAM, etc. So I'm happy with the Terraform plan because everything is creating what I'm expecting. So what I will do is I will just go ahead and run the Terraform apply and provide the plan file. And now it's going to start creating the resources. So it started creating the instance. It has already created the web page, etc. Okay, so it says apply complete. 5 resource added, 0 change, 0 destroyed, which is good. And the output is this web server IP. So before I go into it, let's just quickly see from the command line whether this bucket now exists or not. So what I will do is I will just run gsutil ls and then just grep for config to see if this bucket exists now on my Google Cloud account. So this bucket does exist, and what I can do is I can just look for the content. What does it exist uh, in it? So you can see that there is a web page which we uploaded. So and if I look into it, I should see some HTML file. So here you go. So you see that now there is an index.html, and this is the file which I have in the code, which it has uploaded into the Google Cloud Storage. So that's good. Now let's just take this IP and let's just browse it in the web browser. So if I'm just going it here, so it says Nginx, welcome to the Nginx, and if I do index.html, so yeah, it just basically shows me the web page which I've just uploaded, which is just a contact me, my LinkedIn profile, and the GitHub profile. So that's about creating the resources. Let's say we work for a particular project and we no longer need these resources. We want to clean up and etc. For any reason we want to clean up. What we can do is we can do like destroy to destroy. But before that, I just want to show the change as well. Let's say you have this resource, but you don't. You have this infrastructure and you don't want to destroy, but you have some changes. You have some change requests. I'll just take a simple change request. Let's just say that the environment name has changed from dev to test, or maybe or let's say uh, the application has changed from web server to web server -1, something like this. So I've just made a change to the application tag. I've saved the code. Now what I will do is again, I will run the Terraform init. It's good practice to run the Terraform init. It's not needed, but it's always good so that if there is a new version available or any dependencies, so it's gonna get all those dependencies sorted out. Then run the Terraform plan. Again, let's say 2.plan. So here, what we see is here you see this amber till, so which means it's gonna make some changes. So it says like 0 to add, 1 to change, and 0 to destroy. And also Terraform is can infer these changes, like what changes it can do on the fly, like without destroying the resources. And some changes does require destroying the resources, because that's how the cloud resources works. For example, if I want to change the bucket name, it's gonna destroy the bucket, because to change the bucket name, what it means is like we don't need the old bucket, we need a new bucket with a new name. So it's gonna destroy the old bucket and gonna create the new bucket, etc. So let's just lay, we are happy with this plan. So what I'm going to do is I'm just going to say terraform apply to dot plan, and it's gonna just change the tag of this particular uh, VM instance. So it has made the changes. And let's just say if I'm changing the bucket name, as I said, so again, I've saved the changes. I'm doing Terraform init and then doing Terraform plan out, and it will identify what all resources it needs to change based on these changes. So at the end it says, where does it go? At the end it says 3 to add, 0 to change, 3 to destroy. The reason being, what is happening is, as the bucket name has changed, the Terraform needs to create a new bucket, and the VM instance depends on the bucket because it is looking for an object in the bucket. So as the bucket name has changed, it's gonna replace the bucket resource, and then which means that it's gonna replace the bucket object resource, and the Terraform compute instance is dependent on the bucket object, so it's gonna replace the VM instance as well, and it's gonna say in the code as well why it's replacing basically. So it's saying that okay, this is replaced, and this particular change is forcing the replacement because the bucket name has changed from this to this. For this particular object, this particular thing is forcing the replacement because the bucket name has changed. And for the compute VM instance, because the startup script is will change because this is dependent on the bucket name and the web page. So that's why it's gonna replace this one as well. I'm not gonna run this apply. I'm just gonna leave it as is for now and just revert the changes. And now if I run the Terraform plan again, let's just say Terraform plan 4.plan, it should now say that, okay, there's no changes required, etc. Because we have reverted the code change. So it says that no changes required. Your infrastructure matches the configuration. So that's all about creating the resources and then changing the resources. Let's say now we don't need these resources at all. We want to clean up so that we don't keep spending the money on the cloud. What I can do is I can do destroy, and sorry, I can just do plan and hyphen destroy to see the plan of the destroy before running the destroy. So this is saying that it's gonna remove all these resources. So in the summary, it's gonna basically not going to add anything, not going to change anything. It's gonna destroy everything. So if this is the intended thing, what you want, then just simply run the Terraform destroy command. Terraform destroy. It will again give you the stuff with it. It is going to destroy. Please review that, and if you are okay with this, then only just say yes, and then it's gonna start destroying the resources. So it's now has started destroying the resources. So it's destroying the service account, it's permissioning, it's now destroying the VM instance. So it's destroying resources on the Google Cloud now. It's gonna take few more seconds to destroy it, and then we'll see like whether this will go again to that IP, the web page which we saw. That should be gone now, and the buckets and everything will be gone. Now it's destroying the bucket and everything. So it says the destroy complete and 5 resources destroyed. So let's just run those gsutil command again. So if I just look for gsutil ls and grep for config, this bucket is no longer available. We don't see anything. And if I just look for that particular path, it won't find it because this bucket does not exist. So it says that bucket not found because the code has destroyed the bucket. Now if I refresh this page, see it's keep just scrolling. So if I just open in the new one, it won't find anything because this VM instance is gone. This IP is now released and nothing exists anymore. So this is all about the demo. Now if you guys have any questions, yeah, we can take the questions now. And if you want to reach me later on, you can find me on various platforms. So you can find me on LinkedIn, GitHub, Twitter, or you can follow my blog or the YouTube channel.
Okay, thank you, Pradeep, for the great presentation. I have added link to your blog and to the demo repository to the description of
Thank
this
you.
movie. I will also add links to the slides in a while. And in the meantime, I have one question.
Yeah.
Uh, where we can find you in person on which events you will speak nearly.
Okay, so I'm based out of London. So generally, like for in like it's been for a couple of years. Like yeah, we didn't had any in-person events, but yeah, before that I did a presentation on various like places. So in US and UK and Europe. So different conferences and meetups. Uh, Still like now I think things have in-person events are going to start, so but for now like things are like virtual for me at the moment.
Okay, thank you, Pradeep. If anyone have the question, please ask them in the chat. We have the last minute to ask them, and I will share my slides now. Yeah. As a GDG, we have scheduled a few events in the following weeks. Our nearest event is in the Thursday, 2 weeks from now. It's an Android farewell of the summer. It will be in Polish and, uh, of course, in person. You have to RSVP because number of places is limited. And our next event will be in English. It is in Google office in Wrocław in the November, and there will be various topics, both cloud and Flutter and Angular and machine learning. So all the Google technologies. Okay, I see we have no more. We have no questions on the chat. So thank you, Pradeep, and I hope see you on the some meetup in person.
Yeah. Thanks, Carol. Thanks for hosting me. It was really nice giving a presentation here. I hope everyone has enjoyed. And if you guys have any questions later on, feel free to reach out to me. If you want to discuss any ideas around the cloud automation and anything, feel free to reach out to me on the LinkedIn or Twitter.
Okay,
Thank you,
thank
everyone.
you, Pradeep.
Have a great evening. Thank you. Bye.
Thank you. Bye.